Hello, and welcome to the April webinar presentation by the Underground Construction Association Young Members Group. My name is Colin Sessions, and I'm the Professional Development Chair of the Younger Members Group. I'm joined by Anthony Bauer, the Chair, Shannon Goff, the University Outreach Chair, Everett Litton, the Membership Chair, and Demetrio Kruscalo, the Media Chair. The UCA Young Members Group is a standing committee of the UCA of SME that consists of professionals of all ages who strive to attract and develop engineers and construction professionals under the age of 35. Each month we put on a free webinar on various tunneling topics available to interested parties of all ages. Before we begin this month's webinar, I have two quick announcements. Once again this year, the Young Members Group is hosting a network event at RETC. The network event is being held at the Lion's Share on Monday, June 5th, starting at 8 p.m. We encourage all young members attending RETC to join us. We're also looking for a few sponsors for the event, so if you're interested in sponsoring, please let one of us know. Our information is available on the Young Members website. And for those who logged into the webinar early, saw an advertisement for next month's webinar. Dr. Conrad Felice from CW Felice will be presenting on SEM design and construction. So more information on registering for that webinar will be available as the date approaches. Today, Brad Crenshaw will be presenting on grouting applications for underground construction. Brad is the General Manager of GEC Drilling and Grouting. Brad has worked in the underground heavy civil and mining industries for over 15 years. First with a consulting firm and then working the last 12 years as a contractor. During this period, he has worked with numerous geotechnical applications. However, his experience is primarily focused on drilling and grouting applications. His experiences include various types of grouting operations on tunnels throughout the United States, as well as mines in North America and Europe. Brad holds a master's degree in geological engineering from the Colorado School of Mines. Brad, thank you for presenting for us today, and when you're ready, please share your screen.
Thanks, Colin.
Looks good, Brad.
All right. Can y'all see? So I'll talk a little bit about the presentation here. Whenever I was thinking about this, I figured that a number of people that are listening to this would have very little grouting experience, and some have been around it some, and some have probably more experience than I do. So what I've tried to do is break grouting down into sort of its fundamental concepts, and then talk in a little bit more detail about some of those concepts to confuse the matter, and then at the very end to thoroughly confuse you with some projects that you very rarely see in grouting, but they're interesting. I want to thank everybody. I know that they're taking time out of their dinner hour if you're here in the South, or your lunch anywhere else, or maybe brunch on the East Coast or on the West Coast there. So we'll jump into this. And the way I've set it up is I kind of have done the who, what, where, when, how of grouting. So when we're looking at a grouting project, I guess the first thing that we consider is why do we grout? What is the purpose? And if you look at the dozens or tens of dozens of grouting techniques and applications, and the hundreds or thousands of different grout types, and probably the million plus grout jobs that have been done, then basically it breaks down to just two reasons. There's only two reasons why we grout. The first is to reduce hydraulic conductivity. So either we're trying to keep a liquid, usually water or a gas or whatever, either in or out of the structure that we're building, or we're grouting to do something to improve the structure. And when I say the structure, that could be actually what we're building, the tunnel or whatever, or it could be the structure of the ground around it. And some of the grouting techniques that we see, they're going to do both. So, the who grouts? You do. I don't care who you are, if you are going to be working in the underground industry for any length of time, then you're going to run into grouting projects. Um, so, therefore, you're going to have to know something about grouting. And I think that it's important whenever you're going into a project is to kind of know who the players are. So I've broken it down a little bit for everybody. And so it's a lot of times it's somewhat based off experience. You're going to have people that have done no grouting jobs before, people that have done a few grouting jobs, some jobs, and a lot of jobs. Well, you can generally tell people that have done no grouting jobs. I call them the blissfully ignorant. And that's because these are the guys who are asking questions and they're all excited, but they have no idea of what they're really about to get into. Um, and then we have the grouting experts. And these people are easy to recognize because they come up and they tell you they're grouting experts. They've probably done one or two jobs before. It was probably before a lot of us were born. But another easy way to recognize them is that they probably aren't going to offer you solutions of how to do stuff right, but they're going to tell you everything you're doing wrong. And then there's people that have done some jobs. They've been around it. They may have been intimately involved with some jobs or, just overseeing some jobs. And this is what probably 80 or 90% of you are going to end up being. And those people are knowledgeable and they're good to work with. They know that grouting can be a benefit. They know it's applicable sometimes it's not. They understand the concepts, but they're probably going to go out and get help when it comes time to do the jobs. And then there are those of us, sort of like me, that do a lot of grouting jobs. And the only thing I can say about those people is that they're not quite right. They've chosen a field that can frustrate you and everything's unknown, but those people are good people to have on your team whenever you're getting ready to do a grouting job. What do we grout? And again, this is fairly simple. There's really two things that we grout for underground construction. One is the ground, the other is the structure that we're working on. When do we grout? Grouting can be done at any point during an underground construction job, and it probably is going to be. One of the first things you have to do whenever you're doing underground construction is get down to the level that you're either going to construct your tunnel at or that you're going to do your mining at. And a lot of times for your shafts or your slopes or whatever that access means is grouting is going to be required. All the way down to the very end of the job, when you're finalizing it, you're doing your contact grouting, then grouting can go on at any point throughout the job, and it may even go on after the job. You may go back into old tunnels and regrout them after they've been there for a while. So basically, if you're doing grouting, then you're having somebody breathe down your neck at the beginning so they can get to mining, and at the end so that they can wrap up the job. Where do we grout? Everywhere. All along the tunnel alignment or within the mine workings, then there's applications for grouting at any location you're at. So we'll just run through some of those real fast and where you may do it and what some of the typical applications are at each one of those points along the tunnel alignment. As we've already talked about, you've got shafts, slopes, declines. Primarily, if you're doing grouting in these areas, then a lot of the times it'll be for water control. Also, you may be grouting for supportive excavation. So if you have overburden material you have to get through before you get to competent rock, then you may grout that. Also structural integrity, such as your shaft liner. So if you have a cast in place shaft liner, then you may be grouting behind that just to ensure that it'll hold up over time. Again, at the start of the project, we've got break-ins, we've got breakouts. Often we have to improve the ground outside of the shaft so that when we go to break through that shaft, we don't have problems with the ground. And again, that could be for water control or supportive excavation typically. Alignments. Basically, any type of grouting may be done along the alignment, and it's for various reasons. So we obviously have water control, supportive excavation. If we're in a shallower tunnel that's maybe through soils, then we may improve that ground before we mine through it. Settlement reduction. Oftentimes you could lose ground around or above the alignment. In ground improvement for, say, a mixed face condition where we're expecting to be going through rocks, but then we have some kind of alluvial valley and we need to make that soil more rock-like to efficiently mine through it. And obviously structural integrity of our carrier system, cast in place concrete, rings, or whatever that may be. And finally, any ancillary structures. Basically, the concepts are the same as along the alignments and shafts. The point is just that basically every aspect of a tunnel or a mine may have some grouting associated with it. So we know all these places we can grout or whatnot. So how do we grout? And basically, it's kind of broken down into what I'd call two methods. We're either going to grout, as we discussed before, we're either going to grout the ground or we're going to grout the structure itself. So geotechnical grouting obviously is going to be associated with the ground. And we break that down into 5 main categories. And we'll talk about those in a little bit more detail in later slides, but here you can see the different methods broken out: consolidation, permeation, compaction, jet, and compensation grouting. For structural grouting applications, which are, again, rather than to improve the ground per se, they're going to be to include the structure that we're actually building, then I don't know if you'd so much call these methods, but I've listed some typical applications that are used and that you'll see whenever you're on an underground project. One that's done a lot is angular space grouting. That'll be talked about. That and contact grouting will be talked about a little bit more later. Backfill grouting, where you mined out an area and you need to fill that space in. And you even get into grouting for crack repair of your concrete or base plates under dissipators. And I'm sure there's a bunch more, but again, just some typical ones listed. So going into a little bit more detail on these grouting methods, then we'll go through some of those that I mentioned before. So first off, I've listed consolidation grouting. And the reason that I've listed consolidation grouting first is, in my opinion, this is probably the most utilized method of grouting that there is on underground construction. And that's probably because of the next 2 points that I've listed there, which is that number one is a highly versatile method. Number two, generally speaking, it's relatively inexpensive compared to some of the other methods. And so, you know, it's important to talk about what consolidation grouting is, because I define it in a fairly specific manner. And you can see up there that it's the filling of discontinuities inherent to the rock mass. So basically, for geologists out there, then these are going to be the things that are caused by brittle deformation. So your fractures. And basically, we're injecting a liquid grout into these with the intent of it spreading out in these fractures, filling up the fractures, typically for groundwater cutoff. However, you can provide some structural improvement of the rock also. Another method, permeation grouting, the concept is sort of similar to consolidation grouting, but how you're applying or what you're applying it to is a little bit different, and it's an important difference. So we talked about the consolidation grouting being to fill the discontinuities in the rock mass. Permeation grouting, you're trying to fill intergranule pore space. So basically, if you think about it, think about a sandy soil. You have these sand grains that are in there. They're touching each other, but there's space in between these grains, and that's really what you're trying to fill up. So the space is inherent to the formation of the soil itself, or could be a rock. Sometimes we do run into permeation grouting in rock, and example I see that is like a poorly cemented sandstone or possibly a vuggy limestone. But those void spaces are not caused by fractures in the rock; they're caused by the formation of the rock itself. So I consider that permeation grouting. Oftentimes, permeation is going to be used along shafts and slopes, that area simply because that it's often used in soil. So that's where your soil is. You've got to get through the mine. However, if you've got a shallow tunnel, then it certainly could be used there if you have ground to improve along the tunnel alignment, or if you have rock that needs to be permeation grouted, it may be done within the tunnel along the alignment or whatnot. The cost of permeation grouting is really sort of highly dependent on the type of grout that you use. There's a lot of different types that can be used for permeation grouting, and the cost of those can vary significantly. And it's pretty easy as far as access goes and things like that. Compaction grouting. This differs significantly from the consolidation grouting, the permeation grouting that we just discussed, because in those applications, we're trying to fill void space. We want the rock or the soil to stay where it is. However, with compaction grouting, we're actually trying to move the soil. And the intent of compaction grouting is to put a low slump material in the ground, have it form a bulb so that it displaces the soil, and in so doing, it densifies the soil. So it's going to structurally improve your soil. A lot of the times it's going to be used in tunneling, along tunnel alignments where there's been some settlement to reestablish the ground, locate the ground elevation, also to fill the mat or fill the area below the ground surface where soil has been lost. So it's sort of replacing what has been lost. A little about access. Well, I guess I should say that one thing about compaction grouting is rather a sort of a brute force technique to do this. We'll talk a little bit more about a more precision technique here in a second. But you're putting a fairly large amount of material in the ground to get this densification. So you need storage. You either need room for trucks or storage for material and equipment and things of that sort. Jet grouting. Jet grouting sort of differs from all of the other types of grouting that we're talking about in that it is a partial replacement method. So with jet grouting, you're injecting grout into the ground at high pressures, and the intent is to cut out and remove some of the soil that's down there, and to replace it and replace that soil with a grout, plus mix in the soil that's left to get a sort of grout soil mixture. The thing about jet grouting is that it's probably the most versatile grouting method that there is, in that it works in the widest range of ground types. So if other methods won't work, then sometimes jet grouting will. That being said, it's one of the more expensive techniques. It requires a large work area, and it produces a relatively large amount of waste because it's replacing the ground. The final geotechnical method that we'll talk about is compensation grouting, and I alluded to this a little whenever I was talking about compaction grouting. The two are somewhat similar in what they're trying to accomplish, but compensation grouting is the more precision method for densifying and lifting the ground. So basically, it's the injection of a fairly smaller amounts of a viscous grout. And what you're trying to do is you're trying to fracture the soil and create these lenses, which then lift the ground in slight increments. So a lot of times they do this under like historic buildings or areas that can't take a great amount of settlement. And so you can go in and you can initially induce some heave in the ground, and then you can monitor these buildings as you're mining along. And if you start getting any settlement, you can go into exact locations and do some grouting so that you get some heave and reestablish the elevation you're looking for. One of the drawbacks with it is, if you're doing grouting in an area where there's a lot of buildings, space is probably limited. Plus, you need to be underneath the structure that you're trying to control the settlement. So a lot of times you have to create work areas. As you can see in this picture, basically a shaft has had to be created for the grouting itself. Then just we'll go over some of the structural things that you may typically see along within a mining operation. One thing that's done a lot is annular space grouting. And to define annular space grouting, basically you're filling the void between the surface that was mined and whatever your structure you're building in that space. So, if you mine a tunnel and you put a carrier pipe in, you have an annular space around that. You need to fill that space up so that there's some contact between your carrier pipe and your mined rock face. This is a lot of the times this material is a cellular grout or something of that nature because it just needs to fill up that space. Then another structural grouting technique is contact grouting. So the difference between annular space grouting and contact grouting is that with annular space grouting, you kind of know what that void is. You intentionally created that space to build that structure in. You built the structure to some certain size, so you have an idea of what you need to fill up. With contact grouting, now you're going back and filling up the small spaces that you unintentionally left. So if you did your annular space grouting, there's still going to be some little void up at the top of that of your annular space at the ground. Say you have a cast in place concrete liner, then there'll be void space left behind there from your panning systems and again just from gravity at the ground. So the intent of contact grouting is to fill up that unknown space to ensure that you have intimate contact between the structure that you built and the ground itself. Then, just to throw this out there, sometimes you can get away with combining methods so that you can more efficiently achieve results. So if you take something like modified contact grouting, then that concept takes the methods of contact grouting and consolidation grouting and sort of combines them so that those two different processes can be combined into one operation, which makes things faster and which which makes things faster, and obviously faster reduces cost in a lot of cases. So the point of that is that if you're considering a program, then consider what you're trying to accomplish and try to do it in the most efficient manner. So we've been through some of the major methods that you may see. We'll talk a little bit about the types of grout that you may apply, because with all of those different methods, then the method does not dictate the grout type. After you choose the method, you have to choose the appropriate grout type to work for your method. The most common type of grout that's used is going to be a cement grout. And I run through, you've got various mixtures of grouts. You've got neat grouts, balanced grouts. In those, there can be various types of cement. You have Portland cement, you have different types of Portland cement, you have microfine cements, you have ultrafine cements. So you can take those different types of cements and your grout concept, and there's literally probably thousands of formulations you can make depending on what you're trying to accomplish. You also have grouts maybe that are low mobility grouts, and those grouts are formulated differently and generally have some filler in them so that they don't run as far or don't travel as far. And then you get into sort of more specialty grouts. You have sodium silicates, which are typically utilized for permeation grouting. You have polyurethanes, which they're a very versatile grout to have in your grouting toolkit. And with those, I'd say there's literally hundreds of different formulations for them. There's probably dozens of polyurethane suppliers, and each polyurethane supplier has 20 or 30 different various formulas that they have. You have acrylamides. Acrylamide grouts there's a picture of a set acrylamide over on the right, and what that's showing is that it was a cup that had some sand in it, and then a dyed acrylamide was dumped on top, and then the whole mixture was taken out of the cup. But these are very low viscosity grouts, about 1.5 centipoise, so they will get into fractures that other grouts won't. You have acrylates, which are similar to acrylamides, cellular grouts, bitmous grouts we'll talk about a little later, epoxies for structural repair. But as you can see, there's a lot that goes into a grouting program. So just to summarize real quick, our basics, we have the why to reduce hydraulic conductivity or improve the structure, who you're going to be involved with it, what are we going to grout the ground of the structure, when, anytime, where, anywhere along the alignment, and how. We're either going to use a geotechnical or a structural technique. We're going to choose the appropriate grout type, and maybe we can combine them. So, all of that being said, how do you decide what the correct method is, what the correct grout is, all of those things to have a successful program? Well, there's no cut and dry formula, and there's a lot of things to consider. I listed some of those things here, and there's more. I'll be honest, I just got tired of thinking about it. But you can, certain things need to be considered, and something that's important on one job may not be important on another job, so you really have to look at the situation and determine what's reasonable for your project. I'm not going to go through these in detail, but I did pull out just a couple so that we could talk about some of the things that you have to look at. For any sort of geotechnical grouting, then the number one thing that you're going to have to look at is the ground. I have this little chart on here, and I stole it from Haywood Baker's website. It's a pretty good little chart. It doesn't quite match up with the terminology that I've used, but you can look on it, and it's just set up for soil, but you can see down here at the bottom how jet grouting can be versatile in any soil type. Fracture grouting, which is compensation grouting, As you can see, once we start getting up into larger particle sizes, then it doesn't work, and that's simply because you have a fairly viscous grout, so it needs to be contained. Compaction grouting is fairly versatile, although you can see there's some special considerations for silts and clays. But then when we get into sort of our consolidation grouting, permeation grouting, and things of that sort, then we're limited to the left part of the scale for soils. So they're just not going to work in clays. So the ground tells you some things. Access. You may have to design your program not based off of the most efficient equipment or way to do it, but just how you can. You know, it's one thing if you look at the left-hand picture, if you're sitting out in the middle of a cornfield doing a job. It's another thing if you are inside of a tunnel that's 6.5 feet tall and 4 feet wide. It requires different equipment and methods and procedures. Schedule. You know, I talked a little bit sort of relatively about cost, but I didn't throw out any numbers, and I'm not going to. But, you know, scheduling and cost are intimately related. So do you have time in your schedule to go work at the face, like the picture on the right, where as soon as you start drilling, you're in the area that you want to start grouting at? Or do you have to do it from the surface because you don't have the time to stop and allow the grouting to take place in front of the mining? Or is it more expensive to shut the mining down than it is to have the grout crew drill through soil that they are material they're not going to grout to do the grouting? All things to consider, and there's a bunch, we could spend an entire day going over those. But I wanted to get to some projects, and sort of the intent, as I mentioned, of this is that, number one, to make people think about the process you go through of grouting, sort of as we talked about before. But number two, kind of present you with some things that I think may be interesting. You may not run across that often, and would just be interesting to talk about. So I've got 3 case studies here. And number one, I'm titling it, I've done this 100 times before and it worked. Why isn't it working this time? Which is pretty common sometimes. So we start off and we have a pretty typical project. It's a coal mine, existing coal mine, and we're going to construct a new air return shaft. The shaft's going to be constructed utilizing a raised bore method, which is very common. 16-foot diameter, 310 foot deep. Pretty typical. Could be deeper, but the size is about right. And they had one core hole. It was pretty close to the shaft, but it was only logged for geology. They tell you, and really they tell you where coal is, and everything else is sedimentary rock. So it starts off pretty typical, and they're going to do exactly what they've done before here. And there was a typical consolidation grouting program with Portland cement that they decided to do. And they went through and they did a pretty good job of it. I had all the data for the project and everything looked pretty straightforward, except the grout. There wasn't much grout take. The grout take on the consolidation grouting with Portland was about 9 pounds per foot of drilling, so about 0.1 bags. So it was pretty low, but actually the owner was pretty happy with that. He didn't spend much money on the grouting program, and he was good to go. So they drilled the pilot hole, and oh crap. The pilot hole was making 25 gallons of water a minute. They called in some consultants or whatnot and did some estimates, and based off of what they figured, then whenever they opened the shaft up to 16 foot, it could make 400 to 600 gallons per minute. So that's sort of when we got involved, and we went out and looked at the project. And I'll be honest, luckily we had a little experience, but there was a sandstone layer there that was about 70 foot of the shaft, and we had run into it before and had to use sort of a different method of grouting. There's pictures of the core over there. It's interesting, whenever you pick that core up, if you dump water on top of it, the water doesn't run off the core, it runs straight through the core to your hand. So these pictures are pictures of the same formation. It's in a different shaft, but you can see it looks like pretty competent rock. The surface is wet. That's the picture on the right side. But if you look over on the left-hand side, that's a picture that I got. It's a 3D printout that I pulled off the internet of a reservoir rock for some petroleum project. And basically that rock, or that 3D printout they did there, has about the same amount of void space in it as the rock over on the right. So the issue with this project was that they weren't grouting, or there weren't fractures in the rock like they were trying to grout. There was this very small void space. And so that's why their program didn't work. We ended up getting a program that did, but part of the problem was that they didn't really follow they had done this so many times and it had worked. They didn't really follow the proper procedure. So rather than going in and running some permeability tests, get some packer data, then they just went immediately into the grouting program. If they had gotten the permeability data first, then they would have seen that it took water, but then it wasn't taking grout. And at that point, they would have been able to say, okay, what's our issue here? This doesn't make sense. Instead, they finished one grouting program and then had to go back and do another entire grouting program to make it work. So ultimately, we did a permeation grouting program using acrylamide and a little bit of microfine cement, and whenever they mined the shaft, then it was making less than 5 gallons per minute. The next one, so for those of you out there with faith, y'all know that God has promised us that he will never destroy the world again with water, but there's a clause in there which still allows him to do that to our underground operations. You don't encounter it that much, but there's always a chance that you could hit a large inflow. And this project is about a project that we did where that happened. It was a lime and stone operation. They were going along mining in a pit that they had been mining for years. It had 200 or 300 gallons per minute inflow on a regular basis. But they did one of their production blasts, and one of the areas of seepage started sort of increasing in volume, and 2 or 3 days later they had about 2,500 gallons per minute coming into the quarry. So they were looking at two options. They could increase their pump capacity to handle the water, or they could try grouting to see if they could seal some of this water off. Both were similar in cost, upfront costs. However, they plan to mine this pit for a number of years to come. So based off of the cost of operating the pumping system from that time, they decided to go with the grouting. So whenever you're dealing with large inflows like that, then the best way to deal with them is with asphalt grouting. And again, it's not an application you run into a lot, so a lot of people aren't familiar with it. However, under the right conditions, it can be a very economically viable and successful operation to do. So I've got this picture on here. This just shows the setup from that job, pretty typical setup. On the left-hand side, the green piece of equipment is an asphalt kettle. It's simply the same thing that if you got somebody doing an asphalt roof, that's what they're using. Then you go over to the centerpiece of equipment, the green one there. That is your asphalt mixer. So basically, you're transferring asphalt from the kettle over to the mixer, and at that point, you're mixing it with typically cement. In this case, we were actually mixing it with kiln dust because they had it readily available and free from their lime operations. But the basic things that you need are a very dry material because you don't want to add anything wet to 550-degree asphalt. Um, and something that is going to densify the asphalt. So you want something with a fairly high specific gravity. And that's the reason that the silo is sitting over here to the side, is because we were putting the kiln dust in the silo and then adding it. Just some pictures. Picture on the left, you can see the asphalt. It's a specific type of roofing asphalt. You can see this where we busted up the cylinders. They're sitting over there. And then the picture on the right is the mixed asphalt going into the pump, getting ready to pump into the hole. So for this job, you can see the right-hand corner. That's a picture of the leak. A lot of it's underwater, but you can actually see the fracture going down through the face of the quarry, so we kind of knew what we were aiming for. And we went in and we drilled a series of about a dozen holes. You can see hole number 1 shown in the picture down below of the cross section, about 100 foot back from the quarry face. Dye tested them, got various results. Hole number 1 is the one we chose to start grouting on. It had a dye test time of between 1 and 2 seconds. So we had 2,500 gallons a minute that was moving at somewhere between 50 and 100 feet per second. And that's where we chose to do our grouting. I'll be honest with you, I don't remember what our final inflow was. I went back and I tried to look at my notes. So I did what you do when you have a question, and I asked Google. So what I did was I went to Google Earth, and the picture on the left is the pit a little bit before we started grouting in 2014. And then the picture on the right is the same pit about 5 months ago or so, but this was the most recent picture. So you can see at this point that the pit is pretty much dry. There's a little bit of water down at the bottom on the left-hand side. Finally, one more unique application. Whenever I first talked to Colin, he was asking me a little bit about reverse flow grouting. So we'll talk about that a little bit. Basically, the concept of reverse flow grouting is to use hydraulic head to your advantage instead of to work against you. It's not done that often. A lot of times it's done for shaft recoveries. I didn't have any good pictures of this, so therefore you're going to have to walk through the concept with me with some poor drawings that I did. Now, if you want to know more about it, though, there was a decent amount of this done on the ORS project several years ago. I think there's some papers on it. Some of our current employees were involved with the initial part of that work, but they even adapted it so that they could use it along the alignment, I believe. But here, I'm going to run through the general concept real fast. So here you are, happily mining along, sinking your shaft, and looming below you is a water-bearing feature. You take out your lift, and all of a sudden, there's a geyser that has popped up in your shaft. So you bring in pumps, set them up, and you don't have enough pumping capacity. All you can do is sort of keep it at a steady state. So then you bring in more pumps, finally get the shaft dry, bring in the grouters, and typically what a lot of people do is they go down there, they try to attack it right at the point in the dry shaft, and every time you inject the grout, the hydraulic head and the flow just shoots it right back out at you, and you're wet, and you can't get anything done, and it's frustrating. But if you stop and think for a second, then there might be a better way to do it. So with reverse flow, then you get access to this. So you may have to drill a couple of holes so that you can get some grout hoses to tie into the feature. But then at that point, then you start letting the flow work for you. So now, instead of pumping out the shaft, you pump back into the shaft. And instead of stopping whenever you get to your steady state condition, you fill it up to the top. So at this point, you have reversed the hydraulic gradient of the shaft, and you can start grouting. And now, instead of the grout washing back at you, now the water that you've put in the shaft is pushed out into the fracture where the water is coming from. And so you grout along, grout along, grout along until you get the fracture filled up or to your stopping point. And at that point, you can start pumping your shaft down and kick the grouters out of there and be glad that they're gone and go back to mining. So that concludes everything I had, and at this point, then I will make up answers to any questions you might have.
Thank you, Brad. That was absolutely fascinating. I had no idea it was so complicated. We would like to open up questions of the attendees. If you'd like to send your question to the host through the chat panel, we'll read them to Brad. And like to remind you that the session is being recorded and it will be available on the UCA website within a day or so. All the attendees will receive an email when that is available. Our first question is, did you face any environmental restrictions when using asphalt grouting?
We have ran into questions about that before. We have ran some tests and had the data analyzed, and I'll be honest, I'm not a chemist, so I don't necessarily understand all of the data behind it. But whenever you do asphalt grouting, what happens is the leading edge of the asphalt starts solidifying, and so at that point you're kind of blowing up a balloon from the inside. So there's really not that much transfer of I guess the chemicals from the asphalt to the water. But back to what I was saying, we've had the data analyzed, and the only thing, there is one chemical that is above any sort of detection limit, but we've had to have the data go through various environmental or departments for clients that we've worked for, and they've never had any issue. Also, we've talked to the EPA about projects, and I know, like here where we are in Tennessee, I know that the Tennessee EPA has approved its use on projects. So I guess the real answer is that it's probably going to be somewhat project specific, but actually it's really less sort of environmentally hazardous than cement, because you have cement start washing out, and now you have a pH issue. And so, you know, again, you lose very little actual, I guess, chemicals from the asphalt.
Thank you, Brad. The next question is, when you reheave ground for compensation grouting, how much displacement are you looking for?
And I guess that's going to be somewhat dependent on the settlement that's taking place. But again, this is a precision process, so it is going to be very small. You want to get to the location and do your grouting before much settlement has taken place. So you're wanting to move this in millimeter or at least, no more than several millimeter increments. And if you need to do more than that, you will do it in numerous passes. So you may do it 5 or 6 or 7 times to get to the ultimate heave that you're looking for.
Thank you. Our next question is how to control the grout alignment, especially in case of pressure grouting method from ground surface. I'll read it again. How to control the grout alignment, especially in case of pressure grouting method from ground surface.
I'm not sure that I 100% understand the question. I think that the question may be on drill hole alignment. So the question is, how do you control the deviation of the drill hole if you're doing grouting? I'll be honest. In my opinion, it's not worth doing. You can control. You obviously want to have some control over your deviation, but the methods for steering a drill hole are typically more expensive than just popping another hole. So we do shafts to 500, 1,000 feet, and we don't worry. We design our program so that there's some redundancy in it, and we don't have to worry about the deviation there. So I hope that answers the question. If not, then as y'all requested, my contact info is here at the end. I accept donations, but please don't send hate mail. But you can email me there if I didn't understand the correct question correctly.
Great. Thank you, Brad. The next question is, what are the differences, actually the pros and cons, between high pressure and low pressure jet grouting?
I'll be honest, I'm going to have to sort of punt on this one. I'm not a jet grouting expert. I know just enough to be dangerous. So I will say, you have your geotechnical contractors who do all of this type of work, your Haywood Bakers, your Nicholsons, your Moore trenches. So if it's something that you really need to know, I would contact one of their engineers.
Okay, and we did get a response from the person who asked the grout alignment question, and he said, yes, you did answer his question.
Okay, good.
Good, and I'm getting a lot of messages saying very informative, and thank you for the presentation.
Thank y'all.
And it appears we have no more questions. Brad, do you have any final comments you'd like to leave for our audience?
I'd just like to thank them for their time today, and hope they have a good rest of the week.
Excellent. Thank you. Thank you, everyone, and have a nice afternoon. This ends today's session.